Hello guys, this time I'm gonna introduce you about the memory devices. And first, I'll talk you guys about the SRAM. S means that static memory, and the SRAM's the basic structure is composed like the with two inverter and two controllers with MOSFETs. So if we look inside of the inverter, we can see that the inverter is consists with two of the CMOS. So when we see the structure of the SRAM, there is at least 6 transistors and in one cell. So we call this structure as the 61 cell, which means the in one cell there is a 6 transistor, and see closely there is two lines of the writing line and bit line, and this means that when we studying about the digital design, we learned about the SO latch, and we control the SO latch with the signals of the clock and the writing bit. So it is the matching of the SRAM and digital design. And secondly, DRAM is the pretty similar structure more than SRAM. So DRAM is consists of the one transistor and one capacitor, and so we call DRAM's basic structure as 1T1C, which means that in one cell there is a one transistor. And from the in summary, we can say that SRAM has a high speed of the operation, and DRAM has the lower working speed than SRAM. And as you said before, the basic structure of the basic structure of the SRAM is consists of the 6 transistor, and DRAM consists of one transistor and one capacitor. So density of the device is pretty much higher. The DRAM's density is pretty much higher than SRAM, but in speed quality, the SRAM has a quite obvious advantage. So we use the SRAM like we use the SRAM to the device which needs the cache memories like CPU's ALU model and etc. So, and the other difference between DRAM and SRAM is that the sustainability of the device. At SRAM, if we dividing the voltage source, VDD and VCC, then SRAM never loses the informations about the storage, but DRAM has a little bit problem because capacitor loses the voltage potential. So if time is pretty after few times, then the DRAM's capacitor loses the voltage potential. So when we wrote the 1 bit at the DRAM device, then if we don't do anything, then few times later the DRAM forgets the informations about the storage. So we used to we fixes this problem with the refreshing, which means that after we divide the voltage through the right line, so the DRAM never forget about the information. So in this view, there is a pretty interesting point that when we use the AI, then AI using the AI uses the storage very high frequency, because when we update if we use the nano GPT architecture, then at once with the Adam optimizer, then if we calculate one epoch, then about 20만 개의 GPU uses only the parameter uses 20 sorry 200,000 GPUs to update some parameters of the AI structure. So I think that after DRAM's refreshing would be less important than last few years. That is, thank you. Bye bye.